What's up everybody, this is John with John Fair Innovations bringing you another math lesson. So today I'm going to show you how you can use a coordinate and gradient to find the y and x intercepts. Now before I get to the video today, if you enjoy it, do make sure you hit that thumbs up button, leave a comment on maybe another maths topic you'd like me to tackle. If you really enjoy the video, do make sure you hit that subscribe button so you can stay up to date with all the videos as they come out. Now in previous lessons I've talked about the equation of a straight line and I've also talked about algebraic substitution. So I'm not going to go into too much detail about those, but if you do want more, do check out those videos because there is a lot of content in there that I know you're going to love and enjoy. But today I'll be glossing over those points because I want to more focus on the equation that I've got next to me, which is y minus y1 equals m multiplied by x minus x1. And it's a brilliant equation that helps us be able to solve the equation of a straight line. What actually happens is that if we use this correctly, it'll rearrange and it'll sort itself out perfectly into the equation of a straight line. It's actually really helpful when we're trying to solve problems like this. So we're trying to work out the y and the x intercepts, but in order to do that, we'll need some sort of equation of a straight line. We'll need it in some sort of form of y equals mx plus c. Well, thankfully, we've already been given our gradient. So gradient was given to us as 3, and we've been given one coordinate, which was given as 1032. Now, the way you read coordinates is always to read it alphabetically. So in the alphabet, x goes before y. So in a coordinate, your x component goes before your y component. It's a great way to remember it. Just remember that in the alphabet, x goes before y. So 10 is going to be our x component of our coordinate, and 32 is going to be our y component of our coordinate, our point. So what we actually do is we actually take this information and we put it into the equation that I mentioned earlier. Now, sometimes you're given more than one coordinate. So you would actually have to denote which one is x1, which one is x2, which one's y1, which one is y2. In this case, we've only been given one coordinate. So of course these have to be x1, y1 because we don't have any other coordinate. That little one just denotes which coordinate you're talking about. And it doesn't matter which order you're doing it. You can have it in highest to lowest, lowest to highest. It doesn't matter, as long as you're keeping them consistent. But today we don't have to worry about that too much because, as I said, we've only got the one, so this has to be x1, y1. So our x1 is going to be 10, and our y1 is going to be 32. So now we take that equation that we had before. Our y minus y1 equals m multiplied by x minus x1. And what we do is we put these values in and we'll rearrange it in order to solve. So if we plug in our coordinates, our y1, our x1, and our m stands for gradient. So we just simply put in our value for gradient, which was positive 3. So it's going to now read as y minus 32 equals 3 multiplied by x minus 10. Now our y and our x, because they don't have any denotion of which coordinate they are, we leave it as it is. They're variables. These are meant to stay the same. These are meant to stay as y and x because for an equation of a straight line, they always read as y equals some gradient multiplied by x and then adding or subtracting some sort of constant. So we want the y and we want the x to remain as it is. And now what we have to do is we have to isolate y. We have to get it in terms of y equals. Because our equation of a straight line is in that form. It's y equals mx plus c. So we want this to look like y equals. So firstly what we'll do is we will expand our bracket that we have on the right hand side, which is our 3 multiplied by x minus our 10. So using distributive law, where we take our factor and we multiply it by each component in the bracket, what's going to happen is we're going to have 3 multiplied by x, which would give us 3x, and then 3 multiplied by negative 10 would give us negative 30. So now our equation will read y minus 32 equals 3x minus 30. Now what we want to do is we want to take this constant that's on the left hand side and we want to isolate y. So we're going to take this negative 32 and we're going to bring it to the other side. Now in algebra, if we take something from one side to the other, it always does the opposite. So if it's minus 32 on one side, when we take it to the other side, it's going to be positive 32. So now our equation will read y equals 3x minus 30 plus 32. And as we've got two constants, we can simplify this to bring it to a form that reads as y equals mx plus c. So negative 30 plus 32 would give me positive 2. And now we will have our equation of a straight line. We have y equals 3x plus 2. So now we can use this. We can use this in order to be able to predict points, which is what we want to do in the case of our y and our x intercepts. And how you can do this, you could, as I've done next to me, draw the graph and you could look for the points, or you could use algebraic substitution. You'll get the exact same answer. Now, when we're dealing with our intercepts, it's always in terms of when it's crossing one of our lines. So whether it's crossing our x-axis or whether it's crossing our y-axis. So when we're doing this, we always have to take into account that it is 0 of the other component. So when we're trying to find the y-intercept, for example, this is when x equals 0. And when we're trying to find the x-intercept, this is when y equals 0. So we'll have to do these in two separate states. So firstly, let's do our y-intercept. So our y-intercept is when x equals 0. So all we have to do is plug in 0 for every part of our equation where we have an x. So we have it as 3 multiplied by x. So we just substitute this as 3 multiplied by 0. And what we're going to get now is an equation that reads y equals 3 multiplied by 0 plus 2. Well, anything multiplied by 0 is just itself. So now we've got y equals 0 plus 2, and 0 plus 2 would give us 2. So the y-intercept is when y equals 2. And we can write this as the coordinate as 0, 2, because x component is 0, and our y component is 2. So the coordinate for this would be 0, 2, or when y equals 2. Now we're going to do our x-intercept. And so it's the same process, except this time we need to set y to 0, because the x-intercept is when y equals 0. So our equation now will read as 0 equals 3x plus 2. And now what we have to do is we have to isolate the x. So firstly, we need to get rid of this plus 2, because we can't separate the multiplication at this stage. We have to do that one last. So we will take our positive 2 and bring it to the other side. Now, if it's positive 2 on this side, it's going to do the opposite, isn't it? So it's going to be minus 2. And 0 minus 2 would give me negative 2. So now our equation is going to read as negative 2 equals 3x. And this 3x actually means 3 multiplied by x. So in order to separate this, we have to take the 3 and make it do the opposite on the other side. Well, if it's multiplying by 3 on this side, what do you think it's going to do on the other side? What do you think the opposite of multiplying by 3 would be? That's right, divide. So this is going to be negative 2 divided by 3. And we can write this as the fraction of negative 2 over 3. And this equals x. So this is our x-intercept when x equals negative 2 over 3. Or we could write this as a coordinate as negative 2 over 3, comma 0. And this is in its coordinate form. Or as I said before, if you want to have it in terms of just its x, so then it would be x equals negative 2 over 3. Well, there you have it. You've been able to solve y and x intercepts for a particular line only knowing the gradient and one coordinate. Pretty cool, right? Well, hopefully you enjoyed that. Do practice yourself, because honestly that's the best way to learn these sort of things. But always stay safe, be kind to one another, and I'll see you next time.